Good afternoon. I saw two sensor names today to which I am connected a bit more than 20 years. I saw roses and Earthcare. And this indicates how long it takes from scientific ideas to a high technology instrument in space. And when we started roses, we said industry should get some money to build the first imaging spectrometer ever for Earth observations. When Earthcare was decided a few years ago, and I was chairman of this Earth Science Advisory Committee for ESA at this time, we said, and the margin was not large between other instruments, because we had to select. We said, should fly only if Japan delivers the radar. And it took a long time before a signature could be given. And with respect to what the influence of this sensor would be, the signature ceremony today was very disappointing for me, because there was not a real ceremony. Even our Director General of ESA had no time to finish one sentence, because then our Chancellor was already going away. So next time this should be organized a bit better. Now to Earth observation from space, and I'm on purpose not showing a diagram where ESA is responsible for the data, because we have used an American military satellite mainly for deriving the freshwater net flux out of the ocean or into the ocean from a time series of January 1988 to December 2005. Or in other words, now a public sensor built for the American Air Force was, not the Air Force, the Navy, was a key contributor to Earth observation from space. And we cannot measure it directly. And we are in a situation where remote sensing has become better in many cases than in situ observations. But this is not acknowledged by ordinary people here. How can you measure freshwater net flux over the ocean from in situ instruments? There is no chance to measure precipitation on board a ship. If you have 4 systems running on a ship, you have a factor of 2 to 3 difference in the precipitation amount measured. So it is not done, but we can do it from space. And I will now switch to ESA. So don't expect many more diagrams from other satellite series. Earth observation from space contributes to the detection and exploitation of windows of predictability. All we want is understand the system Earth better in order to extend the windows of predictability. For weather forecasting, we try to reach 3 weeks. This is the end of any weather forecasting. So you can never say in 5 weeks from now, in the early afternoon, a cold front will sweep across Berlin. This is impossible. There are, because of the strong chaotic nature of atmospheric circulation, constraints in the system. But we can extend it if we are satisfied with probability forecasts. We now do forecasts of El Nino or La Nina, 6 months ahead or even a year ahead by using satellite observations of the ocean, direct observations or in situ observations from meteorology. Earth observation can warn of geohazards and can mitigate their impacts. It was shown earlier. Good images can rapidly organize help if political authorities allow help, as the recent example has shown. Even if many satellites exist, the help was not coming because the political decisions were not made. Control of compliance with international law. This will be a very strong future activity of Earth observation from space because it is international, evaluated by a neutral organization or a multinational one. It will be believed. DLR should not do it. It should be an international organization talking about, do countries comply with international law? For example, with the post-Kyoto Agreement. Earth observation from space is the backbone of services. Normally, people have no idea how strong we already depend on Earth observation from space. I will show a diagram in a minute. And we have established this for weather forecasting, as you know. But we have the build-up phase for oceanography, disaster prevention and mitigation, and chemical weather forecast. And Europe will have these services very, very soon. And my dream is that they are as competent as the Met services are at present. And GMES is the component trying to do it. And if you look back some years, there was a lull. GMES was a dying acronym. But then it came up again. And a very strong push was by José Achach, who wrote this famous book, Les Sentinelles de la Terre, where he pointed to these 5 sentinels which were shown. This is a diagram showing you the influence of satellite data on weather forecasting. You see 2 lines for 3-day, 5-day, 7- and 10-day forecasts of weather from the European Center for Medium-Range Weather Forecasting. Earlier, in the beginning of the 80s, there was a big difference between the Northern Hemisphere and the Southern Hemisphere. Our forecasts here in the Northern Hemisphere were much better. And now, the forecasts are nearly equivalent. If I would have added the last 2 years, then there is a slight advantage for the Southern Hemisphere, because satellite data have taken over for weather forecasting. The European Center is assimilating, if I remember correctly, 27 sensors into the starting fields for weather forecasting. It's the leading institution worldwide concerning the use of satellite data for weather forecasting. This is a very impressive diagram for me, and you can turn it into many billions of euros saved per year. Because even a single decision made on a day with threats of heavy rain showers, if 500,000 people believe in the better weather forecast and don't take sandals but real shoes, 500 million is saved. And they can do it, they can use it for better, for a weekend trip. Though it improves quality of life, improved weather forecasting. And unfortunately, people don't use it. You can download it from internet and can plan your Pentecost holidays. Where to go? Where is the chance for above average temperatures or real rain? Because as you know, now the Arabs, the rich ones, are coming to Central Europe in summer, spending their holidays, and they love rain. They are expecting days with rain, and they are now numerous in Munich, for example. Trend analysis with satellites. This is the essence of satellite data in the realm of sustainable development. We need to know what has been changed. And here you see sea level, SST, ozone column, nitrogen dioxide, cloud albedo, solar output. All done with satellite data already. And you can do it because some of the trends are very strong. Then all you need is a 10, 15-year period of observations. And for the sun, look at the last line, no trend. We measure since '78 with several satellites, to which also ESA has contributed, the output of the sun. All we have found is a per mil amplitude in the 11-year cycle and no significant trend at all. I show a slightly different diagram compared to the one Volker Liebig has shown on sea level trends. Why is it different? Here, the annual cycle has not been removed. And since we have a difference in the amount of land versus sea in the two different hemispheres, we have a yearly cycle in mean global sea level. In the northern hemisphere, the warming is a bit stronger during summer and the amplitude of sea level is higher. It is a bump of 2.8 centimeters, which is running from the northern hemisphere to the southern hemisphere and back in 1 year. It is extension of seawater by warming. So we are now in a situation that we, for each of the basins, could tell you every 10 days what the height of the sea level is, to roughly a millimeter of accuracy. This I can overrun, but I point to the tendency, because the image was already shown twice. It's now the third time that you see these ship tracks here. But I will point to China and look at the changes over a few years, roughly a decade, concerning the nitrogen dioxide above China. In our latitudes, nitrogen dioxide is nowadays mainly from cars. But in China it's from power plants, because they do not have scrubbers in most of their power plants. And they open one new major coal-fired power plant per week at present in China. So about 50 are started every year. And this is from Skiamaki, which is an add-on payload, as you have heard, built by Germany, the Netherlands, with a small contribution from Belgium. And then the evaluation is up to the space agency having contributed, in this case, DLR. And there was a financing of the calibration and exploitation phase. But normally, these are very meager programs compared to the costs until launch. And so we lose some information by not giving the equivalent amount for exploitation. This is the sun. And you see how strongly varying the output is from one day to the next week, or from one day to another, because of the size of the sunspots, and the sun is rotating. So you have sometimes a lot of sunspots, and then the output shoots up, despite the sunspots are colder. That's why you see it. But around any major sunspot, the area more brilliant is larger than the area of the sunspot. So you have more emission when you have many sunspots on the sun. And this 11 or 10 to 11 year cycle shows ideally this up and down. On average it is 1 per mil. Challenges to be answered soon. This is a very strongly growing field, Earth observation from space. Source and sink distribution of carbon monoxide, methane, and carbon dioxide by inverse modeling using data from Envisat and METO. We have the most sophisticated sensors for this purpose at present. YASI on METO, for example, is probably the sensor delivering the CO2 column content on global scale to a higher degree than Skiamaki could do up to now. Do we have a balanced European system of Earth observation? It was praised today. As a scientist, I am allowed to ask, is it a sufficient system? Yes, I would say. The answer is at the bottom of this diagram. Very soon we will have this system, and you see the components, the institution, and the purpose. If we would, for example, go downwards with the Earth Explorer Core and Opportunity Missions component, then we try out services. A service is always only good. I know I'm over time, but I'm an independent scientist. I will finish soon. Our services are only as good as the input from experimental satellites is. The gap between the experimental satellites and the operational ones became smaller or narrower. So YASI is an example that sometimes we take the risk to bring a new sensor on an operational system. But this will be not the rule, it will be maybe the first example of exceptions. So Europe is in a position that we are the pushers for a sustainable development using space technology stronger than all the other nations up to now. This may change after the election in the United States of America, but then we have a good companion, and we can push even harder into this direction of a more sustainable development using the real observations on global scale of our planet, which we only can have from Earth observations from space. Thanks for listening.